Alright, the next section deals with the precision standard and identifying the 5-number summary, the gold medal data in standard 1, and construct a box and whisker plot to represent the data. I've rewritten my 5-number summary just so that it's easier for you to read because it's tough for me to write in such a small space. But if we look back at the first page here, number of gold medals 1, you can see that the smallest value there is 0. So our minimum would be 0, and I've written that in there. Next, if we can't figure out Q1 until we figure out the median, and we said the median was 3.5 gold medals, so 3.5 we can go into the median. The maximum we can also calculate is 14. So we'll fill that one in right away. And then the two that we need to figure out are Q1 and Q3. So Q1, remember we said that the median was 3.5. So now for Q1 we want to look at just the values to the left of the median. So Q1, remember you find the median of the medians. So you find the median of that first section. So again, you can cross off, cross off, cross off, cross off, cross off your ones, cross off your ones, or your twos, cross off your 1, cross off your 2, and you're going to be left with 1. So Q1 would be 1. Now for Q3. So if we look at Q3 here, now we're looking for all values greater than 3.5. So again, we can find the median of those. So 4 and 14 we can cross off, 4 and 10, 5 and 9, 5 and 9, 6, oh, I shouldn't have crossed that one off, should I? When we get down to the middle there, there's 2 left. Let me erase that little mix up there. There's 2 left, and they're both on 6. So if I have 2 6s, right in the middle of the 2 of them is just going to be 6. So my Q3 should be, not the eraser, there we go, should be 6. Okay? So with that, I have everything I need to make my box and whisker plot. Remember, the boxes are containing the values of Q1, the median, and Q3. So I'm going to start there. So first my box, starting at Q1, and be nice with my drawing here. It's a little tough on the iPad. And I'm going to go through the median. I'm going to go through all the way through 6. So that's about 6, maybe just a little too much there. There we go. Oh. Cancel. Let's cancel that. Not exactly sure what happened there. And all the way through 6. There should be my box plot. So I have my box. Now I need to show where the median is located. So the median again was at 3.5. So about right there be the median. So that's Q2. And then my whiskers. So my whiskers will go all the way to 0. I'm a little past there, but I have a little dot there to represent that it's at 0, and it goes all the way to 14 here. I don't know what's going on with my page here, but it goes all the way to 14. And that is a rough idea of how your box and whisker plot should look. Obviously, you'd be using a straight edge, so it'll look a lot nicer, but that should be your box and whisker plot. Now, if you want to label the parts, like this would be the maximum, here would be the minimum, we have Q1, and Q3, and then the median. Okay. So there's my box and whisker plot. As you can see again, my minimum is at the end of the whisker. Remember, it's not the entire whisker, it's just at the end of the whisker. My maximum at the very end of the longest whisker. And then my Q1, the first edge of that box, the median right in the middle, 3.5, and then Q3 at 6. The second part of Standard 2 involves the mean absolute deviation. So it says the age of 5 employees at Target are shown in the table. The employee's mean age is the employee's mean age is the employee's mean age is 29 years old. Determine the deviation and absolute deviation for each employee. Then calculate the mean absolute deviation for the data set. So for Tom, if his age is 45, the deviation from the mean is the difference between Tom's age and the mean. So that's going to be plus 16. Okay, 45 minus 19. The same with Melissa. 32 minus 29, the deviation from the mean would be 3. Rebecca, this is a little bit different because now we have 26 and we're going to take away 29. That's negative 3. So we're going to have negative 3 for Rebecca. For Amber, that's even 3 less, so that's going to be negative 6. And for Jonathan, that's even further down the scale at negative 10, because 19 minus 29 is negative 10. The absolute deviation, however, is just how far away that value is from the mean. So Tom's is just 16 away. Melissa's is just 3 away. Rebecca's is also just 3 away. Now it was negative, but when we're just asking for the absolute deviation, we're just looking for how far away is that from the mean. Amber was negative 6, so that becomes 6 away from the mean. And Jonathan was negative 10, that becomes 10 away from the mean. So in order to find the mean absolute deviation, I have to think about what that really means. Remember, the mean is the average. I want the average of the absolute deviations. And in this column, I have all the absolute deviations from the mean. So now I need to just take their average, or their mean. So I add them up, 16 plus 3 plus 3 plus 6 plus 10. If I add all those up, 16 plus 3 is 19, plus 3 is 22, plus 6 is 28, plus 10 is 38. And then I just need to divide them by the total number of people. And there were 5. So my division equation would be, or expression would be 38 divided by 5, which I can easily write as a fraction, and then convert that to a mixed number. I know that I could have 7 wholes there, because 7 multiplied by 5 parts in a whole would equal 35, and then I would have 3 parts left over. So that would be 7 3/5. And then if you wanted, you can convert that to a decimal, but you don't need to. It's a decimal, we'd multiply by 2/2, that'd be 7 6/10. But the mean absolute deviation will be 7 3/5. 7 3/5 years. Okay. So again, we took the average of all the absolute deviations. And that's standard 2. Not too bad. Hopefully that helped. Hopefully you're getting ready to go for this celebration. Thanks.